I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode, we'll tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 43. We are in our holiday unit.
Yay!
Cheryl, do you like the holidays?
Oh my gosh, I love the holidays.
I thought that might be the case. So are you excited about this unit?
Yeah, I mean, like the only better unit would be just being on winter break. But since we're not on winter break, this is a pretty good unit.
And also, if we were on winter break, we wouldn't be doing this because we would be on break?
Yeah, and that's great when you're not in school. So,
True.
yeah.
Even teachers like that.
Yeah.
Well, last week we were doing Halloween.
Mhm.
What are we doing this week?
Well, now we are counting down the days to Thanksgiving, which is going to be here before we know it, even
Mhm.
though right now it's a couple weeks away.
Okay.
And so I was thinking about Thanksgiving preparation since like we're not at Thanksgiving yet.
Right.
Probably like I'm not, it's not time for grocery shopping quite yet
Okay.
or any of those final things. It's more about preparing for Thanksgiving.
Okay.
And one thing people do before Thanksgiving Day to prepare for it is they brine their turkey.
Okay. Yep.
So I thought we should start with that.
Start with what?
Let's brine a turkey.
Do you have a turkey? Because I don't have one here.
No.
And it's going to be hard for us to brine a turkey.
Okay, let's just like verbally brine
brine a turkey. Do you have a question about brining? Is that what you're getting at? And I'm just being difficult?
Yep, exactly.
Okay, got it. So what's your question about brining?
What is brining?
Oh, okay.
Yeah.
Like what even is it?
Yes.
And maybe like how does it work or why do people do it?
Maybe. Yeah.
Okay. Well, let's start with the pre-assessment. Do you know what brine is?
I'm going to say salt water.
Okay. Salt water.
Mm-hmm.
And what makes you say that?
I feel like I've heard that.
Okay.
I think if that's true, it's just like at some point I've heard somebody say that.
Okay.
Is how I would know that.
And then brining the turkey, what does that involve?
I think you soak it for an extended amount of time in salt water.
Okay.
I think I've brined salmon before. I was following some recipe and it had you brine it first. And then just recently, so I work for a catering company, and just recently I heard our head chef talking about some pork chop we had, and why it was so good was that you brine it first and that makes it moist.
Okay, so that gets at the next thing is what is brining supposed to do? You think it makes it moist?
Locks in moisture,
okay,
maybe, is what I'm hearing. And then you can also buy turkeys pre-brined, and I think the idea with that is then, skips a step that you have to do.
Mm-hmm.
And it's just one of those things. It's kind of like when you read a recipe and it tells you to sear the meat before you continue to cook it, or like even a crock pot recipe. It's like sear it first and then put it. And brining feels similar. And we're like, but really? Like, are we really doing anything here? Or are we just feeling like fancy chefs?
Oh, okay.
So I'm curious, like, what does it actually make a difference? Or is this just something that we say?
Kind of like salting pasta water?
Yes, like that, or like toasting your quinoa before you cook. I mean, there's all sorts of little cooking things like this.
Mm-hmm.
And this is one where I'm like, okay, we talk about brining. We have a pre-brined turkey.
Mm-hmm.
Is this actually helping my turkey dinner?
Okay. If it were to be a real thing that was actually helping your turkey, how do you think it might work? Why would soaking the turkey in salt water as opposed to just water? If the point is to make it moist, why would you need salt as opposed to just water?
Well, I don't think you would want water because one of the steps commonly in cooking meat is to pat it dry. And like
Okay.
another thing you could do, like before I cook chicken, is I pat it dry and then I put oil on it. And that's also supposed to help it hold in
Okay.
the moisture. So I'm wondering if the salt's similar where I mean meat just like leaks a lot of its moisture while it's cooking.
Okay.
A lot of it's just coming out. And so I'm wondering if it's creating some sort of a barrier that salt
Okay.
water maybe is like making an outer barrier where then the other juices of the turkey aren't escaping into the pot or the pan. They're just staying in the bird.
Okay.
I don't know
So to,
what it would I don't know why it would do that, though. Like, what is it about salt? That's not something I know about salt. That's something I know about oil, is that water and oil don't mix. So I'm like, well, maybe
okay.
they don't wanna, like, pass each other because there's oil there.
Mm-hmm.
But then is the salt doing the same thing? And I'm guessing that has to do with molecules.
Oh, okay. You think molecules are involved.
Yes. Actually, I
Okay.
know molecules are involved because we're talking about matter, right? So then, like,
Mm-hmm.
molecules.
Oh, clever, clever. Okay. Any other ideas about what the salt might be doing when you're brining
Flavor?
the bird? Okay.
I mean, we use salt in cooking, so, like, I'm assuming it helps with the flavor.
Have you ever had a brined turkey before?
I'm sure probably most of them, especially if
Okay.
they come pre-brined commonly now, then I probably have.
Okay. And you said salt probably contributes to flavor. Do the birds taste salty?
I mean, I don't think, like, salty in the way, like, just eating some salt would, but
Or just, if you've over salted something and it tastes
no, it doesn't
salty.
say it tastes over salty. Although even when I cook a chicken, the amount of salt I put on it feels like, "Oh, that's gonna be too much," and it's not. So, no, it doesn't taste overly salty.
So then what does salt do for flavor?
Well, it does, it just brings out the flavor that's already there,
Okay.
unless you're over salting something. But if it's soaking in, then it's just gonna bring out the turkey flavor more as opposed to, like, dumping salt on it.
Okay. And this may be a question for a whole separate episode, but I think it is. But why would salt bring out another flavor instead of
That's a
tasting
different
like
lesson.
salt?
Yep.
Yeah. Yeah. We may need to write that one down because I feel
Yep,
like that's a whole
I think so.
nother piece there. Okay. All right. Well, that's a good starting place that we can kind of build off of. In order for me to explain this, Cheryl, I think I'm going to need to draw some diagrams again.
Yay, I love when we have visuals. That's awesome.
There will be visuals. I have to warn you, they're not going to be super amazingly high quality visuals, but there will be visuals.
I mean, yeah, we're in science class, not art class, so I guess that makes sense.
This is true. That is very true, in fact.
Well, this is a good reminder then for me to share with our listeners. If anyone is just listening to our podcast, you can also head on over to YouTube and check out these amazing visuals on
That's
Ryan's
right.
untitled whiteboard.
On my untitled whiteboard, exactly right. In order to understand what's going on with brining, we need to understand a concept that you probably learned in a previous biology class, most likely,
Okay.
but you may or may not remember.
Okay.
It's called diffusion. Does that word
Diffusion.
sound familiar at all?
Yeah.
Do you have any idea what it means?
Diffuse. To diffuse.
Uh-huh.
I can think about diffusing light.
Okay.
Like before we started recording, we were talking about my lamp over here and how I could throw a sheet on it. And I was thinking, oh, that would diffuse the light, meaning it would scatter it more evenly.
Okay. Yeah. Spread something out a little bit.
Mm-hmm.
Yeah.
Yeah.
Yeah, that's in general what it means. Specifically, what we're going to talk about is when you've got things with cells, because turkey being a formerly living thing, I guess when we eat it, it's not alive anymore, is made of cells.
And oh my gosh, I was right. It has to do with cells.
You said molecules.
Oh. Okay.
But there are molecules that make up cells. So sure.
I forgot there's a
difference. do you remember what the difference is?
You just told me that molecules make up cells. A cell has different parts to it.
It does. And even those parts are bigger than molecules.
And molecules have like individual elements in them.
Right. Like, remember one, go ahead.
Like H2O.
Exactly. Right. H2O, which is water. That's a water molecule. And remember, I've showed you the cute little water molecule model again.
Yes.
Right. With 2 little hydrogens and 1 oxygen.
Yep.
Right. That's a molecule. Now, not all molecules are as small as water. That's a pretty small molecule. Some molecules are really, really big, like a protein. You've heard of proteins. Proteins are usually really, really large molecules. They're very, very long, twisted things. And we're going to talk about proteins here in just a little bit.
Oh, interesting. Okay.
The concept of diffusion in the context that we're talking about is a very simple idea. It's the idea that when things can move around freely, they move from wherever there's a higher concentration to a lower concentration. So they try to even out. So if you have a whole lot of something on one side, and I'm just drawing a whole bunch of dots on one side, and you have a lot less of it on the other side, the one where it's a lot of them all together are going to try and move over to where there's a lot fewer of them to try and even things out.
I mean, that makes sense. I'm just picturing a crowd of people and how if all of a sudden you have more space, you're going to spread out more.
Exactly. And the reasons for it actually go back to when we did talk about molecules, and molecules are always moving and they're bumping into each other. And when you have them closer together, they bounce off of each other more and start to spread out if they have the space.
Like when they looked like they were in a popcorn popper.
Like when they looked like they're in a popcorn popper. Exactly right. So that's the basic concept. Does that make sense so far?
Yeah.
Okay. So now let's move to our example of brining. So if I draw our turkey and I try and draw like the bucket that it's in.
I don't see a turkey.
Sorry, I need to scroll. There we go.
Oh, yeah, this is not art class. Okay, continue.
I warned you. Right, and so we've got the brine. And in the brine, there's water and like salt and sometimes other things. Sometimes you'll also put like a little bit of sugar in or some other, like some seasonings and things like that. Sometimes people put those things in, right? And then you've got inside the turkey, you've got all the stuff inside cells and water. Making sense?
Yeah.
Okay. So inside the turkey, you've got all this stuff inside cells. And I'm just drawing all sorts of little dots to represent all of those things. So those can be things like proteins and amino acids and sugars and all sorts of other things that make up the cell.
Okay.
And then that are inside the cell. Okay. Whereas out here in the brine, you've got, some of the salt. Let's say, if it's a really simple brine, you just have salt, which means there's a lot more space for water to be in between all of those salt molecules or compounds.
Okay.
Is it making sense so far?
Yeah, because like a lot of the turkey is a solid and there's not a lot of solid in that brine.
Yes. Well, you can argue that there actually isn't any solid because it dissolved. Remember back when we talked about dissolving?
Yeah. Okay.
So you are dissolving the salts. So it's not really solid. It's still there. It's just not solid. But there's a
Okay.
whole lot less space inside the turkey cells for water to exist because there's a whole bunch of other things.
Okay. Yeah.
So there's a higher concentration of water in the brine and a lower concentration of water in the turkey cells, which
Yeah, that makes sense.
means the water is going to move from the brine into the turkey.
What?
Because it's going from where there's more of it, a higher concentration, to where there's less of it, a lower concentration. Does that make sense?
Yes, but that's just surprising. Interesting.
What makes that surprising?
I don't know. It feels like the turkey would want to be turkey and the water would want to be water.
Well, under normal circumstances, it would, but the turkey is dead and defeathered and
Okay.
right is not typical turkey now.
Yeah.
As far as a living thing.
It's not a turkey in a swimming pool. It's a dead animal. But it's just really interesting. It feels like there'd be enough of a barrier. Although I guess my fingers get pruny when I'm in the bathtub for too long.
Yep. And there's a lot of reasons for that one.
Okay.
But also, this is also why you usually will brine a turkey for at least 24 hours, sometimes multiple days. This process doesn't happen quickly. It takes time for the water to work its way into the actual turkey cells and into lots of the different turkey cells, as opposed to just the ones on the outer edge.
So if it was not salt water and it was plain water, would it do that the same?
Not quite. I mean, yes, there would be some of that happening, but not quite. And I'm so glad you asked because that's the other thing that's also happening. So I'm going to need to make another little drawing here. So let me move down. We're going to basically recreate my same thing, my amazingly well illustrated turkey. And for those of you who can't see this,
You're missing out.
It's so close to what an actual turkey looks like. Cheryl is confused that it's not actually real. She's tried to reach out and grab it several times.
Yeah, I'm also confused that it's not alive because it's just like so realistic.
Yep.
Yeah.
And I'm never sarcastic ever. So the other thing that's going on now is, again, remember we said that we had salt, right? And we had salt out here in the brine because that's what we put in there. Salt. And there's some salt inside the turkey cells as well.
That makes sense.
But there's less salt in the turkey cells than there are in the brine. So there's a higher concentration of salt in the brine and a lower concentration in the turkey cells.
Okay.
What do you think that means, Cheryl?
Well, Ryan, the higher is going to go to the lower as it diffuses.
There you go, which means the salt is also going to move into the turkey cells. And that's going to do a couple of things. The most important is, remember I talked about those proteins that I said were big, long molecules?
Yeah.
Salt is actually able to sort of pull apart those big, long molecules so that they're much less tough and they're a lot looser, which softens the meat. And it allows the meat to hold on to that water more effectively.
Whoa.
So in addition to the water going in, there's also salt going in, and that allows that water as it goes in to stay there and for it to absorb even more water. Wow. Because one of the things you mentioned is when you cook meat, it tends to lose water and liquids, right?
Yeah.
And that's a known thing, and that's true. But by adding more and allowing the meat to hold on to more, even if it loses the exact same amount of liquid when you cook it, it started with more after brining. So it will actually be more moist because you actually allowed it to have more water to start with.
That's very cool. And then is part of why it doesn't, because you were asking me about the flavor, like if
Mhm.
it's like really salty,
Yeah.
is is it because the salts are in there, like breaking up the proteins and things like that? Does that make them not taste so much like salt anymore?
That's part of it. Part of it is, yeah, the salt is doing other things and interacting with other things there. But also, salt, if it's not a high enough concentration, like you sort of said, it doesn't really taste like salt.
Yeah.
It just enhances pre existing flavors.
Mm-hmm.
And if we want to get into that, like you said, I think that's another episode,
Mm-hmm.
another lesson. But that's a great question that I think it would be great for us to tackle at a future time.
Okay.
I think that's most of what you talked about. You did talk about their maybe making a barrier. Do you think that that's what's going on now, that the salt is creating a barrier?
No, because it's inside of it. It's not like just on the edge
Right.
of it.
Right. That was a good idea. And when you talk about searing, that is one of the things that searing is sort of doing. So you're not totally crazy, but in this case, it's not really creating a barrier. It's kind of doing the opposite, right? It's allowing things to pass through the cells.
Yeah. Mm-hmm.
Right.
Yeah.
But I think between those two things and our good friend diffusion, I think that explains why you would want to brine a turkey.
Nice.
And next up, Cheryl, is your favorite part of the lesson, the quiz.
Oh my gosh. And what I'm going to do is I'm going to just like cook for you as my quiz, because I feel like this was more of like a cooking lesson.
That's
And
great. You know what? I'll fully accept that if you can show me your brined turkey.
Okay, I'm going to get back to you on
Okay.
that in a couple weeks.
Oh, okay. In the meantime, we should probably do the quiz then. But nice try. First question. What is diffusion?
Where things that are in a higher concentrated area, they will move to be more spread out to the lower concentrated area. And it can be all sorts of things.
It can. You know, another great example of diffusion?
What?
Axe body spray. Do you remember that from middle school?
Yes, but what about it? The fact that you can smell it everywhere?
If you spray it, just do one spray in one part of a house or a room, and then you have people in different parts of the room, they'll all smell it at different times as it slowly spreads out and fills the room.
Specifically Axe body spray.
Well, I mean, that's the one that's the most memorable for most people.
Middle school.
Next question. What are the two substances that are important for brining, and which direction do they move?
Water and salt, and the salt dissolves in the water.
Okay.
And they both move into the turkey over time because the turkey has less water ratio wise in it, and also less salt in it.
Less than.
The brine.
Okay. Well, here's the great thing, Cheryl. You actually just answered the next two questions all in that question.
Are you serious?
Yeah.
So my very thorough answer paid off today.
It totally paid off. Yeah.
But so what were the questions?
Why does the water move into the turkey, and why does the salt move into the turkey?
Oh, yay.
Yeah. See, that's how well you're doing.
Oh my gosh, that's amazing. Well, I'm getting so ready to go start brining my turkey.
There you go. We got one final question though.
Oh, okay.
What does the salt do inside the turkey cells, and why is that important?
It breaks down the proteins, which makes them more delicious.
Okay.
And it helps the turkey to hold on to its moisture. Water.
It does. Yep. It allows those proteins to be a little bit more flexible. So it also tenderizes the meat a little bit. And yes, it allows them to hold on to the water and creates a little more space for the water to fill those gaps as well. So nice job.
Good job, salt.
Good job, salt. Salt is actually very impressive. It does a lot of very useful and
Right?
yummy things as
Yeah.
well. Yeah, salt is pretty cool. Great job on the quiz, Cheryl. I'm thinking you probably want to, go start thinking about brining your turkey. My dad has done it for years, and it makes a huge difference.
Nice.
He also barbecues his turkey.
Ooh, it's so good.
It really is. And then he started putting bacon on it.
Okay.
During the barbecue. Oh,
okay.
yeah. Oh, yeah. It's good stuff. And his brine is not just salt and water. He's got all sorts of stuff and all these fancy things. He goes all out when he does it. It's very impressive. But
amazing.
Yeah. So why don't you go ahead and get all your stuff and get ready for that. And while you do that, you can pack up and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.